Most folks look at factories as a way to ship faster. They'll say like, oh yeah, you'll get a little bit of slop, but my God, you'll launch so much more features, like the cost return, the ROI will be worth it. I think that's a very short-term phenomenon. Every team has backlogs of bug fixes or improvements that they wish they could be making. With a software factory, the idea of a backlog kind of goes away. So how do you get to a software factory?
So we're here in SF for AI Engineer. And of course, you're giving a session tomorrow. Tell us a little bit about the session that you're giving.
So the talk is about harness engineering, or maybe more broadly, factory building. Mm-hmm. So it's a bit more advanced of a talk, but we go through people who are maybe at a point where you're using agents interactively, but you've kind of gotten to a place of multiple sessions at once. You are pretty frequently one-shotting easier tasks. Maybe some more medium complexity tasks also land without much human intervention. And you're starting to ask, what's the next step? How do I go further? And so the talk will walk you through, from that starting point, how do you get to the broader software factory vision, where pretty much all of your end product is being delivered by some sort of an agentic system. And then you and your engineering team are focused more on improving the quality of the agent and the system around it. So how do you make them require less human intervention? How do you make them require less review from yourself? And then the sort of dream at the end of it is, how do you then, once you've got those pieces in place, start actually improving the quality of what you're building beyond what you could have done before, because you have so much more bandwidth and output through the factory itself.
And software factory, I guess it's a newer kind of term that people are using, but people maybe unwittingly are on that journey as they build more automations and as they are using multiple agents and longer running tasks and those types of things. They're leaning into that style of development, right?
I think that this is an area where I'm sure there will be people who disagree with me on this, but at Tesla, we don't really view the software factory as this sort of monolithic end game that it's like, once you're AI native, you can do this. And it's more of just steps along the way. It's like, as you delegate more work to agents, sort of everyone is on the software factory journey. It doesn't actually require a lot of complexity or like being far along the adoption curve to start thinking about what you're building as a factory. It's just about we split it into sort of three big categories. So the first is you have to think about the autonomy of agents that you're working with, right? And so everybody's worried about this now. How do I make it that agents require fewer human corrections, fewer human interventions as they work? So you could think of like really high autonomy means you give a prompt to Claude Code or Codex and it just runs for 30, 40 minutes, and what you get at the end is right. It doesn't require correction. So that's, I think, where a lot of people start. It's like a good place to start getting productivity gains. Then you start moving into automation, which sounds sort of similar to autonomy, but it is actually how much are you allowing agents to build without human oversight. So you can actually have very high autonomy, but low automation if you don't trust the agent's output.
And that's the key thing, right, is that trust. And how do you actually gather that trust? What is needed to be able to have that full autonomy?
So some of it is just getting used to the tools, learning where they'll be successful, where they won't be. But a lot of it will come into something that we go into in the talk, this new discipline of harness engineering or loop engineering. So we break this up into, there is the inner loop, which is basically what the agent is iterating on as it is building. Right? You can think of this as the plugins, the skills, the test suite that you have access to for the agent. These are things that are fast. The agent sort of checks its work as it goes. The better this is, the more the agent will sort of land at the right solution.
And of those tasks, how much are very individual versus shareable things that the rest of the team can kind of use?
Yeah. I would say there's two scales. If you're talking about within the repo, almost all of it is shared. And in fact, at Tesla, as we've been sort of working on our own software factory, I know this is something said more broadly as well, we sort of outlawed any local configuration. We think like everything needs to be checked into the repo so that if you make an improvement, it improves for everyone. You get that sort of compound loop. If you're talking about the broader, maybe across your organization, across a few different repositories, there will be some amount that is specific, right? Like a workflow that is about building a specific feature within a specific code base, or hooks, test suites, et cetera, that you're not going to share. But there will be things that are very common. Your style guide, your design system, your security policies, all of that. And those you'll want to share and hopefully have everybody at the company benefit.
Yeah, and almost like mandate, this is what we need because we're all contributing to the same base. So that's the middle. That's the very center.
That's the inner loop, And then basically you can think of the inner loop runs with the agent until it puts up its PR. And the outer loop is what you run at the PR boundary. So these tend to be deeper, slower, maybe slightly more expensive checks that you wouldn't want the agent sort of cranking on infinitely as it works. But they do make sense if they're replacing human review time. So this is where you put things like Agentic QA, where you'll have agents running through test scripts, actually trying out your product. This is where you can put like deeper code review that might be a little bit more expensive, a little bit slower. This is also where you can put things like TESL verifiers, which I think we'll talk about a bit. But these are the things that you actually hope that they all are green right from the start, and you actually kind of plan it that way. But they are what give you that safety, that confidence that this code is good. I don't have to, say, pull down the PR and do some manual verification on my own, or read every single line of code that's been written. And so that's what we call the outer loop. That's what will build your confidence.
So that inner loop is typically very much a developer. Developers are very much integrated with that loop and using that. The next loop out, would you say that's more in the CI kind of space on PRs? So it's outside of what a developer would more locally run?
Yes, it pretty much exclusively will run on some kind of CI hook. And as I mentioned, the sort of hope is that the faster inner loop checks catch pretty much everything. And they've gotten the agent to a place where it is pretty much spot on every time. The outer loop is intentionally run in a separate process. It's slower, it's more expensive. It's meant to just be your final gate check to make sure no mistakes have been made.
Right, okay, so that's the two loops.
That's the two loops. There's a third loop, the meta loop that goes around them all. You can think of this as the continuous learning. So as you're building both the inner and the outer loop, they won't be perfect. Things will slip through those checks. You will review, you'll have to do code review. You'll find issues, you'll leave comments. You might have CI checks that fail, et cetera. The meta loop is sort of sitting in the background observing this process and then automatically suggesting changes to improve the inner or the outer loop so that basically you only make a mistake once, right? Like never tell the agent more than once how to do a thing before it gets codified somewhere in the inner or outer loop. And so this meta loop is something that a lot of people, the meta loop to start is humans, and we can go into why that makes it hard and why that will leave you sort of stuck at local maxima. But as you make it increasingly automated, that's when you'll really start to see the sort of exponential growth in how much the agents can do on their own.
And when we look at these loops, what I find fascinating here is as we see adoption, we're really seeing, I guess, people starting in the center. And as they grow more mature and as they start building these processes out, they start getting further and further and further out into a more, into a fuller, more complete factory.
Basically, your bottlenecks will just keep moving as you work, right? And at first, the agent just can't even put up a good PR, and so you'll put all your time there. Then the PRs will be good, but you still don't trust that you have to do review. This is where I think a lot of people in the industry are right now. The code review is the new bottleneck, I think, comes out a lot. So then the outer loop will help you work through that. And then people, that's where they really want to start pushing the limits of how big a task can I give, how, we've heard the echoes of token maxing here, like how do I get it to where it's like a 9-hour task that just runs to completion? You're only going to get to those kinds of extreme, like positive outcomes with some kind of a meta loop that is slowly ratcheting up the quality of your agentic system.
Right. And in your talk tomorrow as well, you'll mention a little bit of TESL, and you'll talk about how we've built TESL agent to satisfy a number of these different ways. Now, one of the things that it actually relates back to my last point there, when people kind of like have these loops and they start in the center and they slowly build out and they grow their usage of a software factory, they don't just go, here's a software factory, just add water, and all of a sudden, I'm using a software
Unfortunately,
factory.
no. I wish.
And so one of the things that I love about the TESL agent is, you can go at the pace, or TESL agent is ready to go at the pace that you are ready to grow at. And so if you want to start right there in the middle and right in there in the center, absolutely you can use TESL agent for those types of things. And then as you build out, and as the organization culturally are going to change and adapt and adopt, they can use more and more of the Tesla agent and allowing that to kind of like build out this factory for you.
Yeah.
So tell us about the stages of how you bring Tesla agent into your session.
So a lot of the design and build of the Tesla agent and Tesla's platform in general is rooted in our own experience trying to get Tesla itself to be more of a software factory by design. So maybe I can use that as an example, because a lot of the things we've built, they'll almost be sort of like walked through in the same order of pain that we felt. And we talk to customers, we see that most people tend to roll out or hit these problems in the same rough order. So the first thing that we did at Tesla was we focused on getting the control plane right. So I mentioned how you want to have these meta loops running that are observing how the system is behaving, finding common errors, making them better. You can't do that if all of the feedback and insight into issues is locked away in opaque places. So if you get your control plane right in such that all of the feedback you're giving is in very legible places, everything else will be easier. So it's a great place to start the process. And this can be a little counterintuitive because it sounds like a very advanced way of building, but at Tesla, the first thing we did was we effectively set a few goals, a few ground rules we were going to try to abide by. The first was no more human written code. The second was no more interactive coding agent sessions. So that was the big one where we got gasps from the crowd when we first went to it. Nobody wanted us to take away their Claude Code or their codex.
Two people collapsed out of sheer fright.
The vapors, they fell back. But it turns out it's not as extreme as it sounds, right? Like if you're to the point where you're already managing multiple agentic sessions and getting pretty frequent one-shot for simple to medium tasks, you'll actually find that where we wanted to move was you file, in our case we use linear as our task tracker, so you file a linear ticket, an agent will pick that up, and it will get through to building a PR, and then you will code review against the PR. It sounds like an extreme leap, but I think a lot of people found that was actually how they were building already. Right? They would ask the agent to do something, they would switch away to another tab, it would run completely unsupervised until it was done, and then they would review the code locally and effectively provide PR review via the chat interface. So it's not as big a leap as it sounds, and once you do this, now everything is running through like a very persistent ledger. Right? You have the issue contains the initial prompt. You have the PR with all of your feedback, all of your, if you've got like a code review tool or something, all of that feedback, all in very durable places that are easy to pull down with open tools. And so it just sets the groundwork for that continuous loop. So when we started moving to this, the first thing that we hit was we built our own little agentic orchestrator. Pro tip, it's not as hard to build agentic orchestrators as it maybe sounds. And so we believe that it's something you want to own yourself. You can customize it exactly to your company's needs. But when you get started, we had Maria, a teammate on our research team. She built the first version of the orchestrator, and she used her own GitHub credentials for it. And so there was a couple-week period where all of our PRs were coming from Maria, and all of the follow-up comments. She quickly shot to the top of our contribution list, which was, I'm sure, fun for her, but also not great for her notification inbox.
I mean, her productivity, it must have looked amazing.
Through the roof.
Yeah, absolutely.
Through the roof. So there's a lot of things you build very quickly just to say, you need a linear app, you need a GitHub app, then you need them to be able to talk to each other so that you can delegate issues to that linear app, and then it will fire off something that runs in GitHub. So,
and these are things everyone will need. These aren't like very specific to Tesla. This is anyone who does this is going to likely.
If you want to work in this way, if you want to assign tickets to agents and then have them put up a PR and respond to feedback, you're going to need solutions to this. And you're going to hit problems around identity. You're going to hit problems around webhooks and reacting to comments that are left on the PR. And so Tesla, just to make that easier, we built it for ourselves, and then we sort of turned it outward for other folks. We have the Tesla linear app, the Tesla GitHub app, very basic, very unopinionated. All they do is wire those two things together. So on either end, you can define what kinds of labels, what kinds of information you're putting in your linear ticket, and then what kinds of workflows are being run on GitHub. We just handle that wiring for you and the identity part so that you don't have to worry about it.
And that's not something like, from a Tesla agent point of view, that's not something necessarily that is mandated. That's something that if you wanted to do that, and if you're ready to step forward to do that, that's something that you can just implement.
And that's something, as I mentioned how, I think as we were building within Tesla, we came to the conclusion that this was something we wanted to really deeply own. Right? Every time we tried to use an off-the-shelf orchestrator, we found it's great, for getting from 0 to 0.5, but actually getting to a place where you can use it in production all the time. There's just so many little quirks to your team and your company that having a black box tool own your entire SDLC it quickly grates. And so we wanted to be able to configure, we wanted to be able to pull in our favorite tools, et cetera. And so almost immediately we committed to the way that Tessel helps you build your factory has to be open and modular. It has to allow, we have defaults, we have things that if you don't want to care about it, you can just get started, but it's easy to pull them out and replace them with something you either built yourself or your favorite tool. We really, really strongly believe that this space is so broad, there's not going to be a single player that is best in breed at every single part of the development lifecycle. And even for people who are best in breed, they still won't match every single peculiarity of your development flow. And you want to retain that ability to customize. So we have, like you mentioned, Tessel Linear app, Tessel GitHub app can both be pulled out. You could make your own. You could swap in someone else's. And then once you have that, the last piece you need to sort of set up this control plane is somewhere to run the agents, right? So you can start just running them in GitHub Actions, and actually that's where we began as well. You'll quickly hit a bunch of little things, right? Like GitHub Actions, they're not the cheapest place to run cloud actions. They also, they're not built for like multi-hour long running tasks. You'll have to set up like a little sidecar that renews your GitHub tokens. Again, permissioning auth, like a lot of times GitHub Actions don't have, they aren't allowed to then trigger follow-on CI/CD actions. And so we built again, just a very small tool called Tessel Launch Skill. It's a CLI command that lets you codify a workflow you want to be run as a skill, and then just kick it off into a cloud container that Tessel hosts. Again, you don't have to use it, but it has all the right defaults. It will post with the right identity. It has the GitHub credentials. And so once you have all those pieces together, you now have a very simple way to say, OK, I can quickly get myself up and running with, I file a ticket, that triggers a GitHub workflow. The workflow will pick a skill, launch it in a cloud environment that is better built for long-running tasks. That skill can then post back to the PR, leaving comments or putting up the PR to begin with. And that gets you started with that control plane loop. Very focused right now on linear and GitHub because that's what we use within Tessel, but we have more coming soon for all the different services.
One thing I love is as an organization starts building out their processes, it's very much, sometimes you get analysis paralysis, right? Where it's like, okay, we want this thing. Now let's have this huge thought process about, well, what's the right tool? What's the best way of doing this? And actually, the best way of doing it is almost like to start with something. Understand what works, what doesn't work, what you need to change, what you need to adjust, and actually then you realize, it's like you need to live in a house before you work out how to where to arrange your furniture. And so it's a really nice way of quickly getting up to speed and then saying, actually, this is fit for purpose, this is good enough. Or do we need something that actually works a good way? Do we need to handcraft something, or do we need to buy something else to replace and plug it in? And it's that extensibility as well as that good defaults that allow you to get up to speed quickly and then decide what you need.
This is something we've seen across pretty much every successful customer who started moving towards software factories and resonates with ourselves as well. Trying to treat it as a single monolithic like lift and shift of like change everything about how you work is just sort of doomed to fail. First, the industry is changing rapidly still, and so trying to commit to a 3-month build out that in 3 months is going to look very different is hard. But second, it's the same thing of like agreeing to your style guide, right? Like everybody knows how much pain that's going to be. Everybody has different opinions. It's so much easier and so much more likely to stick if you can just almost like a reverse jawbreaker, right? Like layer on piece by piece, like just find a workflow that everybody can kind of agree, put a box around it, and then set it up to run automated. Or find a couple playbooks for how you build features, add them as skills that can then, when you start a new feature, you apply a label to the issue to use that skill. Just keep it simple, just work piece by piece. As you layer on more and more, after a few months, you might find like, wow, 60% of what we do is automated and doesn't require human review. It was never a big step. It was never a big argument where you had to get the whole team aligned. You just go with what works. It's much easier then if one piece doesn't work to just roll it back, rip it out, try something else. And so again, the Tessel agent really tries to internalize this. It's designed to help you move step by step, one workflow at a time, It is not trying to migrate you from where you are today to a software factory in overnight.
It gets you to that place that you're most comfortable with, and if that is a software factory, then you can build it out using Tesla.
Exactly.
There's one thing before we jump into your session, which is going to be it's weirdly tomorrow, but
by the magic of editing.
Yeah, exactly. I want to talk about one thing which I think a lot of people kind of like jump to as almost like the first thing that they want to add in, particularly when they want longer running agentic flows, which is going to be reviewing that code.
Yes.
And I think from our point of view, from a trust point of view, from a validation and verification point of view, you need to be able to have a good reviewer there.
Yeah.
Now, of course, Tesla has their own that you can use, and again, it's like you can swap it out. You can, if you prefer a different code reviewer, you can pull that in. But talk us through Tesla's code reviewer.
Yeah. So again, just sort of walking through the timeline of as we were building our own factory. As soon as we got the control plane in place, the next biggest problem was we're getting all these PRs. How do we review them more effectively? And I think this is common across the industry. Even before you start moving towards issue tracker to PR, getting flooded with review becomes a pain point. So we found that there were 3 big components that we needed to tackle that kept coming up in our own code review. So the first is what I'd call just your general agentic review. It's just you want someone other than a human who sits down and has a set of rules, and they look through every part of the diff, they look through the rest of the code base, and they just give a pass. They leave get rid of all the low-hanging fruit. And so we built we call Tesla change review, which is a command that you can run. It comes pre-built with a bunch of lenses for how it can review the code. So it can look for security issues. It can look for areas where readability is poor. It can look for areas where you're not reusing existing pieces of your platform. Like a classic one is it uses the standard logger instead of your custom company logger. We have a few more, but they come out of the box covering what we think are like the common things you're going to want to look for. But importantly, I mentioned we think everything needs to be open, everything needs to be customizable, because this really is your new discipline, is building this factory. So the Tesla change review is powered by skills. So you can very easily, as you start to discover more things that you care about, you can add in a skill on your particular style or your particular approach to accessibility or visual design, and make sure that all of those are being reviewed in this agentic review. So that's kind of like your base layer, right? That catches most things.
And just to add, I saw some internal chat from Amy, who was she was so happy.
Code review extraordinaire.
With the amount of really good insights, actually useful insights that the Tesla, I think it was the default plugin, right?
Yes.
That
the default 5 lenses that we apply.
She was really so exciting. She was so excited. She was like very, very, very talkative about how amazing these different issues were. So definitely one to try for people who want to.
It's sort of surprising, I think, as models are getting stronger. One, they're getting easier to use, right? So now there's a world where you don't have to have a full team prompt engineering the heck out of your code review guidelines just to get good results, right? What's more important is actually just good, sound engineering principles stated plainly to the agent. And so it's a lot easier to own your own code review now than I think people maybe who got started a year ago would be familiar with. But then I think given how deeply agents can look, it makes it very clear how we're going to move towards a world where actually agent and agent-written code is higher quality, not lower. I think right now the narrative to some people is, if you move to a software factory, you're accepting lower quality in exchange for higher throughput. I think that's a very short-term moment as we make this migration, because what we have found as we moved to your point with these new 5 lenses for code review is that at first, when we were applying that on human-authored PRs, all the engineers started complaining. They said, it's too much feedback. Like, I don't have time to fix all of this. This is pedantic. This doesn't matter. Like, sure, in a year when we scale, like, I guess I could do these things, right? The very human, like, I don't have capacity for this. But there are real issues. Like, they could actually improve the quality of the code you're shipping. Now, when it's an agent on the other end, it's just like, great point. Let me go fix all these things. Right?
Absolutely.
And there's like, it's just like the capacity to fix. Like, there's no such thing as a backlog anymore. And so, if an agent can identify a problem, it can be fixed. And that's what gives me hope that in the sort of medium to longer term, we're actually getting to a place where the code we're shipping is higher quality, not lower. And it'll be faster, and it will be more fun to build. So yeah, that's the change review portion. I can go into the others unless you have
no, I was going to say kind of like one of the big things, I guess, is if you give an agent like a huge list of things that it needs to kind of like check, very often it will maybe do like 80% of them and things like that. I'm really curious to dig in a little bit deeper into the verifiers, which kind of like solve some of these problems.
Perfect tee up. So once you have your general agentic review, that's great at catching big classes of problems, sort of unanticipated issues. But the next biggest source of problem you'll find when you're doing code review is there's a long laundry list of things you've told the agent to do that just sometimes they get forgotten, right? It's like 95% of the time you're good, 5% of the time it'll mess it up. That's probably better than humans, but you have to think through like, how do I catch those mistakes? Because I want it to be 100%. I want to sort of lock it in. And I don't want my general code review, like you said, to become this laundry list of, make sure every front-end element has an ARIA attribute. Make sure every design uses this particular hex value of green, et cetera, et cetera. So what we introduced is a thing called verifiers. The easy way to think of this is very small, fast, cheap, LLM-powered linting rules. So the idea is, usually as a start, we'll look at the skills you have in the repo, but you don't have to power them with skills. You can just be any issue you care about. You'll define something that like an invariant, you want to be true. Like every front-end component must have ARIA attributes, or these are our design colors, or every instance of logging must be our internal custom logger. You define those, and then what Tessel will help you do is create a bunch of targeted LLM checks that look for, you define like a set of glob patterns for files that it could affect. It can be the whole code base if you'd like, but you can also target it to reduce cost. And then it will give a bunch of focused, does this file contain a front-end element that does not have an ARIA attribute? Or does this file contain any call to a logger that is not this logger? Very easy. You can basically get 100% reliability these days. Like agents effectively never miss those, or LLMs. Go ahead.
No, I was going to say, but and that stage is very deterministic, right? Because it's like it's going to run that, and it's going to make, and it's going to do the check at least. And when that check is very, very small, like you say, it has a very high success rate.
You keep it very scoped, very black and white, and I think a lot of people, again, they sort of, if you've gotten started, you can almost a curse of knowledge. Like a year ago, people knew that even routine, straightforward commands to an LLM might be incorrect. Nowadays, it just like really doesn't happen. Like if you ask an agent, does this JSX element have an ARIA attribute on it? It's going to get it right 100% of the time. And so what you do is you set all these up. You can run them in parallel. They're fast. They're cheap. You run it like, actually, in fact, we usually add it to our linting and testing rules so that whenever the agent puts up a PR, you just have a green check that says everything you have said in your skills or every little mistake you've ever seen an agent make was not made here. And that really closes the loop on, if you think of the agentic code review will catch things you weren't anticipating. The verifiers catch any problem you've ever seen so that it never happens again. And it gets back to the only correct it once.
It's almost a little bit like the activation problem of a skill, right? It's down to the agent to whether it activates the right skill or not. Whereas with these, and in a code review, is it going to activate these various checks that are needed?
Will it look for every piece?
Whereas we know it's going to be done every single time.
Exactly.
Amazing. This was super insightful. And I really appreciate you talking about how Tessel itself has been on the journey and how we're turning those learnings into really kind of like, product features through the Tessel agent. So super, super valuable. Why don't we listen to you in more depth with your session at AI Engineer now? Over to you, Drew.
So, quick introduction. My name is Drew Knox. I'm the head of product and design at Tessel. Tessel is an agent enablement platform. We help you go from scaling skills to building your own software factory. So today I'm going to talk about a few things. The core is going to focus on harness engineering, which we see as sort of the new discipline of agentic development, and how you can use it to ladder up to a software factory. So before we get started, a few prerequisites. This is a bit of an advanced talk in the sense that if you aren't already using coding agents, what I'm about to walk through is probably not where you want to get started. So I'm sort of assuming that if you're working with coding agents, you're used to having a couple sessions at a time. You've gotten to a place where coding agents will, for like easy tasks and maybe medium complexity tasks, frequently do the right thing. You're sort of at the sweet spot for starting to think about harness engineering, starting to think about a software factory. What I'm going to say here is not exclusive to that, but that's where you'll get your best results. So I'm going to walk through a few things. First, I want to define software factory and talk a little bit about why you might want to build towards one. Second, we're going to then focus a lot on harness engineering, which is kind of the core practice or skill that you'll use to reach a software factory. We'll talk about what are going to be the components you work on while you're doing harness engineering. And finally, I'll walk through how the Tessel product briefly can help you along that journey. But most of the topics I'm going to talk through here today work with any stack. They're mostly techniques. Tessel makes them easy, but they're not exclusive to us. OK, part one, software factories. What are they? There's no strict definition. I'm sure you're all probably as frustrated as I am with how quickly terminology changes and migrates in the industry today. But roughly speaking, a software factory is any agentic system where all of the end product of what you're building and shipping to users is created by agents. And your software engineering teams effectively focus on building the factory. So they work on making the factory more autonomous, more automated, and raising the quality of what it produces. I'll go into each of those terms in just a second. That's kind of the core idea of a factory, though, is everyone on your team effectively becomes internal tool builders, and then you're building a system that produces your product. So I mentioned 3 key metrics. These are sort of like the pillars you need to think about when building towards a software factory. And they sort of go in this order. So autonomy is effectively how much human intervention do you need to get to the right answer. So how many times do you need to correct the code or provide a nudge on how the agent should be building. Automation, I've got them flipped here. Autonomy is the first one. It's how much do humans have to correct. Automation is how much can you let them run, right? How much do you need to review or build trust in the solution before you accept it? They sound quite similar, but there is a difference. You can have high autonomy in the sense that agents frequently are one-shotting the problems you're giving them, but low automation because you don't trust it yet. And so you're reviewing all of the code directly. You are manually verifying everything. So they are distinct things that obviously have a connection, right? You have to build up autonomy first before you can move to automation. The final quality, probably the most self-explanatory, how good is the product that you're actually producing for your users? These metrics are like your usual user analytics, your test quality, your test coverage, et cetera. As you work towards a factory, you're going to go improving autonomy, then improving automation, all while keeping quality constant. And then the sort of payoff at the end, why would you want a software factory, is that ultimately we think you can raise quality once you have a factory. So talk about this a bit. I think most folks look at factories as a way to ship faster. They'll say like, oh yeah, you'll get a little bit of slop, but my God, you'll launch so much more features, like the cost return, the ROI will be worth it. I think that's a very short-term phenomenon, right, as agents are sort of coming online and getting better. In reality, yes, you will move to higher velocity with a factory, but every team has backlogs of bug fixes or improvements that they wish they could be making that they just don't have time to do, or explorations that they wish they were doing. With a software factory, the idea of a backlog kind of goes away. And so you actually just have much more capacity to work on test quality improvements, architectural refactors. So at Tessel, we believe that, yes, at first, as you transition, you will want to keep quality constant, or maybe like a very small dip, but that the ultimate payoff is you should see better quality in the code that you're producing. Also, it's great for your overall team collaboration styles. So once you've moved to a software factory, it's much easier for people who aren't in technical roles to contribute ideas. So it's easier to explore more and to have more perspectives coming in and contributing, while your engineering team is much more focused on building the underlying system that everyone is using to push features out to your users. So I think ultimately it leads to a more dynamic and inclusive development experience. So how do you get to a software factory? Harness engineering, as a sign of how fast terms evolve, it's also started to be called loop engineering over the last couple weeks. This is really the core discipline that you're going to take to get towards a software factory. At its core, harness engineering is, I mentioned the software factory is building your product. You are building the loops that automate and improve the quality of your factory. So what do I mean by loops? What are the loops that you might be working on? There are 3 core concepts. Each maps to a certain phase of development. So you have your inner loop, which is as the coding agent is working on a PR before it has put it up, right? So these are very fast, iterative loops. You want them to be cheap. You're expecting the agent to run them all the time. Improvements here will drive better autonomy. They help catch things and correct the agent without your coming in and human intervention. Once the PR is up, you move to the outer loop. So this is where you're going to put more expensive, exhaustive checks that don't make sense to run over and over again as the agent is iterating on features, but they do encode things that otherwise a human would have to verify to build confidence in the system. And so this is because they're more expensive, but they are taking away human review time, they can be worth it, right? So this is where you might put something like Agentic QA, or where you might say, like, run mutation testing to check the quality of our test suite. This is for expensive things that you want to run once when the PR goes up, and then have the agent iterate on the results. Finally, you have the meta loop. This is where you'll drive quality. So the meta loop sits outside of the development process. It observes your coding agent logs. It looks at PRs, your issue tracker, user feedback. And it's basically finding mistakes that are making their way through the pipeline to your users, or that you had to correct as a human to stop that from happening. And it feeds back into the inner and the outer loop to make sure that that mistake is not made again. So the outer loop is what really kind of, once you have the infrastructure for each of these loops, the meta loop is where you're going to be actually driving from a certain percentage of like how AI native am I, you're going to be driving it up by investing in your meta loop. Before we get into like what are the components, what do you do to actually accomplish this, I think full disclosure up front, harness engineering, at least raw unassisted harness engineering, is hard for a few specific reasons that basically come down to human psychology. So the first, hopefully this one will go away over time, but it's a new discipline and it's changing very fast. And so a lot of teams that get into harness engineering, you basically become an AI researcher just to try and keep up. You're reading papers, you're watching blogs, you're coming up with best practices that go out of date the next week and then 2 weeks after that. And actually at some point they become anti-patterns and you don't want to do them anymore. And so there's just like a lot of time and space you'll devote to keeping up with how to do harness engineering. And so if you want to get into this discipline, you need to have a sort of upfront approach to how you're going to solve this problem. How are you going to make time and space to keep up with the knowledge that's changing every week? The second, and this one is more durable in my opinion, harness engineering is fundamentally unplanned work. So you will start shipping a feature. You have no way to anticipate, will agents fail? How will they fail? How long is it going to take me to fix it? And all of that work that you're going to do to try and make the agent better competes with shipping, right? So it will slow you down from getting the features out. And we all know that is just a perpetually hard trade-off to make. You either don't do it and you get stuck in the local maxima of the agent never improves, or you do it and you miss your deadline for the feature and you get in trouble, and so no one ever does it. The final piece is that once you've solved these initial problems to like make time and space for harness engineering, you'll find that a lot of the information you want access to is not available. It's hidden away in local coding agent logs, or it is on someone's machine somewhere, it's in someone's head. A lot of the signals that you want to see to make agents better, you need to do some work to move your workflows onto surfaces where everything is saved and publicly available for later optimization loops. Okay, with all that aside, then what are the pieces that you should be working on as you're doing harness engineering? I've broken it into 3 layers. These aren't by any means standard terms, though if you want to help me make them so, I would be forever grateful. The first layer, and these are sort of like in the order you need to do them as far as Tesla is concerned, is you have to get your control plane right. And so I mentioned how most of the data that you want to have access to make agents better and move towards a software factory is not legible. If you move your workflows into, for example, at Tesla, we have all work starts as an issue on the issue tracker. It gets sent to a headless agent running in a sandbox. The agent puts up a PR, and then engineers engage with comments on the PR. So it still has manual correction, it still has manual interface, but now all of your touch points with the agent are legible. So you can then point tools at them to pull that information down and make things better. Typically, the 3 things that everybody comes to when they're trying to set up a control plane is you have some way of tracking issues and kicking off agent work from that. You're going to have some way to review. GitHub PR review is probably like the easiest. And then you're going to have some way to standardize and distribute workflows, playbooks, things that make the agents better. Typically, that ends up being something like a skills registry or a shared GitHub repo where you push skills that improve agent quality. Next is a massive grab bag that I call Agent IT, which is if anyone's ever tried to move like a project that had a lot of local config into something that someone else can set up, and you realize with horror all of the dependencies that you thought were cleanly isolated and are not, you basically are going to have to go through the same thing with agents. There's going to be all these things that you thought were easily accessible by an agent, right? Like CLI, API access, giving a way for the agent to click through your product, to build it. I promise it's worse than you think. Like there's no one who has come in thinking like, yeah, it's not going to be that hard for us, has left saying that at the end. And so there's just like a lot of pieces you'll work through. And this is probably the most unplannable and most like spend a week, spend 2 weeks and just get it done. But it will come through things like writing down in your company brain how you get work done, what are your workflows, et cetera. You're going to have to give access to all your internal services, which will require governance and like API access questions. You're going to want to give a way to access production logs. And that's going to have its whole own question of like, what's your compliance stance, things like that. And then you'll need an environment where the agent can execute the code that it is running. There's infinite more, but they're generally pretty company specific. And you'll just work through as you try to get agents to put code up without you intervening. You'll quickly learn what are the problems. Finally, this is where you'll end up spending most of your time. These are the improvement loops. So these are the things I mentioned before, the like inner, outer meta loop. These are components that tend to go into your meta loop. So repo maintenance, you're going to want things that sweep your code base every day, every night, every week, something like that to look for problems. You're going to want playbooks for common development practices, so how to add a feature to your CLI. You're going to want to find a way to identify repeated tasks and automate them, and ideally as quickly and easily as possible, because otherwise people won't do it. And then you're going to want something that looks at the output quality just on a consistent basis and brings back improvements and learnings to the rest of your code base. So say things like, oh, I saw the agent made this mistake. Let's update a skill on like the playbook you have for adding features to the CLI. Let's update that so it doesn't make this mistake again in the future. So those 3 control planes, Tesla sort of exists to try and help you solve them. As I mentioned, everything I've said before here are just techniques. You could go do them all yourself if you wanted. There's plenty of tools that do that. So I'm going to talk a little bit through how Tesla will help you if you want to use us. To start, why would you want to use us? So we focus really hard on making it relatively iterative and sustainable to get to the cutting edge. So we try to make it like a bunch of small lifts rather than one massive snake eating the moose all at once. We're batteries included, so we solve the knowledge gap by saying we will keep up and you will have an agentic experience that basically knows the best practices of harness engineering, is kept up to date on your behalf. We have a real commitment to being modular and open, so we don't think every component of a factory is going to be best in class with a single company. We want to make sure you can pick and choose what is the most important piece for your stack. And then, like I said, we focus on making it easy. So we have automated loops for you that you can install and just react to the changes that are proposed. And we really try to make sure it's just incremental steps so that you, 6 months later, are like, oh wow, we're like 40% there to a software factory. We never had to stop and delay shipping or anything like that. So the first place that Tesla helps is in setting up your control plane. We have a skills registry where you can publish and version the workflows and the automations that you're working on with built-in governance, things like security reviews, quality reviews, controls for who can publish and update what. We also have easy connectors for issue trackers to GitHub. Right now we're focused on linear to GitHub, so you can basically file a linear ticket and get it to run a GitHub workflow, with more connectors coming soon. And then we also have a suite of tools for code review. So to make it easy to set up your standards for agentic code review as well as more targeted checks. See here an example of something that had like a workflow that has been posted to the registry being scanned for security, quality, and how much it actually improves the agent's output. After this, I'm going to play a video while we talk. See how this goes. So we have an agentic experience called Tesla Agent, which will help you with creating and then maintaining your improvement loops over time. So the first thing that we do is we will help you with that change management of like, how do I actually make the time to find repeated tasks and set them up in automation? So the agent will mine through PRs, issues, things like that, and find like every week you do a hunt for flaky tests. Why don't we just set that up as a skill for the workflow, and then we'll put it in automation on a GitHub action. So we help you actually make time to do the automations, just like one workflow at a time. The second is that we come with a lot of out-of-the-box maintenance tasks. So I mentioned you want to have weekly scans for things like architecture quality, code duplication, how good are your test suites, do you have any security vulnerabilities? So if you use Tesla, you can just sort of like one-click install a bunch of those things and just get weekly improvements to your code base without any other effort. And then finally, we offer a way to turn any skill into an automated workflow. So it's through a command called Tesla Launch, where you effectively take a skill that codifies a workflow. You can then pick a particular coding agent that you want to handle it. Tesla Agent can be one of them, but for most coding tasks, you probably want to use something like Codex, Claude Code, Gemini. We have access to all of them. And we will run them in a sandbox that has the appropriate permissions, can be long running. We'll have GitHub tokens so that it can put up a PR and respond to comments as you leave them. So it just makes it really easy to automate workflows like that. And so with these things together, we just make it really easy to get started and just one at a time, find an improvement, take a workflow, turn it into a skill, ship it to everyone, and then get your improvement loops going. What you're going to want to focus on as you're doing this work is driving down manual takeovers, driving down human PR comments. So these are like metrics that you can track to see like how far am I towards software factory. And then over time, you want to see more PRs initiated without human input. That's a sign that you're automating more. And then, of course, you want to first hold quality constant and then aim to drive it up after that. That's it. If you want to learn more, Tesla booth is just that way. Please give a scan, come over, see us. We'd love to chat. Thank you all for your time.